Let's take a look at the homework for lesson 6.1.2. Try to do this on your own first if you haven't already, and then use the video where you get stuck. So the first question says, what do you need to know in order to calculate concentration? Well, concentration is the number of moles per liter. So you need to know those two things, but sometimes it can seem like you don't have everything that you need. You might have grams, which you need to divide by the molar mass in order to calculate the moles. Sometimes you're given milliliters, which you need to divide by 1,000 in order to get it into liters to use. But ultimately you need moles per liter. For question 2, it says I've got 3 different solutions. One is a glucose solution, 1 liter of 1 molar, C6H12O6. And then I've got 1 liter of 1 molar C12H22O11. And I've got 500 milliliters of 1 molar C12H22O11. Which 2 solutions are tied for having the most molecules? Well, solution A and B both have 1 liter of 1 mole per liter. That means they both have 1 mole, which is 6.02 times 10 to the 23rd molecules. So solution A and B both have 6.02 times 10 to the 23rd molecules. Solution C only has a half a liter of that 1 mole per liter. So that means it has half as many molecules. Which solution has the greatest concentration? Concentration is the molarity. All 3 are 1 mole per liter. And the last one, which solution has the greatest mass? Well, solution A and B both have 1 mole's worth, but 1 mole of sucrose, C12H22O11, is going to weigh more than 1 mole of glucose, C6H12O6. So the solution with the largest mass is solution B. And we'll say sucrose has a higher molar mass than glucose. Number 3 says, describe how you would make all steps the following solutions. What if you're given a bottle of solid sodium chloride and you're supposed to make 100 milliliters of a 4 mole per liter solution? Well, let's figure out how many moles we need. We want to make 0.1 liters of a 4 mole per liter solution. So how many moles do we need? That means we need 0.4 moles of NaCl. We can figure out its molar mass by using the periodic table. 1 mole of Na, 22.99 grams, plus 1 mole of 35.45 for chlorine. That comes out to be 58.44 grams. Multiply that by 0.4, we need 23.4 grams of NaCl. But now I need to describe how I would actually make it. So I'm going to say put this much salt in a 100 milliliter volumetric flask and fill to the line with water. Number 2, this time we want to make 2 liters of a 0.05 mole per liter solution. So how many moles do we need? We need 0.1 moles of NaCl. just like last time, we've got to figure out how much in grams that is. 0.1 moles times 58.44 comes out to about 5.8 grams of NaCl. So similar to part A, or letter A I should say, we're going to put this in a 2-liter flask and fill 2 line with water. What if the scenario is different and we're given a stock solution, 0.5 moles per liter sodium chloride? How could we make 100 milliliters of a 0.25 molar solution? We've got a 100 milliliter volumetric flask. Awesome. Well, I know we're going to use the equation M1 times V1 equals M2 times V2. My stock solution goes in M1's place, and V1 is often what we're solving for. We want to make a 0.25 molar solution, and we want to make 0.1 liters of it. I'm going to divide both sides by 0.5. V1 comes out to be 0.05 liters, which if I multiply by 1,000 is the same as 50 milliliters. Again, I got that by doing 0.25 times 0.1 divided by 0.5. So what does this mean? I would add 50 milliliters of the 0.5 molar NaCl solution to a 100 milliliter volumetric flask and fill to the line with water. Let's take a look at the second question here. Again, we've got a 0.5 molar stock solution, and this time we want to make a 0.2 molar solution, and we want to make 250 milliliters. So I'm just dividing that milliliters by 1,000 to get it into liters. Now I want to divide both sides by 0.5 to get V1 by itself. 0.2 times 0.25 divided by 0.5 is 0.1 liters. That is the same as 100 milliliters. So just like last time, or similar to last time, I would put 100 milliliters of the 0.5 molar stock solution in a 250 milliliter volumetric flask and fill to the line with water. And that will dilute it so that my new concentration is only 0.2.